Alright, this is your 8.1 homework set. Inequalities and systems of inequalities. So when we're graphing an inequality, we just want to do a couple things. Well, one I'm going to show you just basically the gist of it, how to use this tool, and then also how to use your calculator to help you. So if I'm graphing this, first of all, I can treat it just like this is y equals. So ignore the fact that that says less than or equal to, and just treat it like it's y equals the line 2x minus 1, or 2x minus 4. So initially, a couple things I have to decide is, one, am I using a solid line or a dashed line? Alright, that goes to the fact if this is greater than or equal to, less than or equal to, greater than, less than. Alright, if there is a underline here, then we use the solid line. Alright, if there is not, if this has just been strictly less than, then we would use this dashed line. Okay, because of that or equal to, alright, we're going to use solid. Alright, now how do I graph a line? Just treat it like it's a line. So 2x minus 4 is where we're going to start, and then 2x is the slope, so rise 2, run 1, there's a point. Okay, so there's our line. We do want it to be solid. Okay, but now less than, this means the y value, the y coordinate, is less than the things, less than or equal to the things on this line. So here's the line, this is the line 2x minus 4, but y can be anything less than that. So just anything on that line goes straight down, like this point would work. This point would work. What is this point right here? My cursor is. It's the point 2, negative 5. Will that work? 2 times 2 is 4. 4 minus 4 is 0. Is that greater than negative 5? Yes. Okay, so anything in this region below that line also works. Okay, less than, we go below. So I'm going to shade it below that line. There's my answer, and then I check it. Okay, so a couple things you have to keep in mind. One is the dash thing. This is a solid line because of the or equal to, and we have to shade below or above it depending on the sign of the order symbol. Alright, now the way this works here on your calculator, you isolate y. Y is already isolated here. So when I go into my y equals screen, I type in what's there. So 2x minus 4. But then after you've got it typed in, come over here to this, beside the y1, this little thing that tells you what it's going to do. Right now it's just going to plot it with a line. Okay, but if we want it to go above or below, shade above or below, depending on the order symbol, we have to tap the enter button a couple times. Alright, so there's a solid line. Right now that's going to make a solid line versus a thin line. And then there's our greater than. That's going to shade above the line, and that's going to shade below the line. So now I hit graph, and it shades below the line. Okay, so that verifies that we got the correct answer. And we already have it, but that kind of just shows what it would look like on your calculator. Alright, now if it's not isolated, then you'll need to isolate it. So here I got 2x minus y is greater than or equal to 8. Okay, I'm going to subtract this 2x over, and I've got negative y is greater than or equal to 8 minus 2x. Okay, divide away the negative 1. Alright, to get that y isolated. We want y, we don't want negative y. Now what happens when we divide by negative? Remember, your order symbol flips. It was greater than or equal to, now it becomes less than or equal to. Alright, and then we divide a sum or difference by negative. All your signs change. So this becomes a negative 8 plus 2x. Or, the way I would write it, lead with the positive 2x minus 8. Alright, just switch these two, switch their places. So this is what I'm going to put into my calculator. I've got y isolated. That's what you want to use when you're going to use your calculator. Alright, so go to your y equals. I'm going to clear it out. Notice when you clear out, it automatically takes away the less than or greater than. And now I'm going to put in 2x minus 8. Don't try to put in the y and the order symbol. Just put in 2x minus 8. Then go back to the front afterwards. And then this is a less than or equal to again. So we're going to go below. Alright, so there's what I want. Alright, now again, if you need help on here, alright, or equal to, so we're going to use a solid line. We need the line tool to start off. We're graphing 2x minus 8, so we're going to start at negative 8. Start at negative 8 on this. Alright, and then 2x means we rise 2, run 1. So there's our line, and then don't forget the shading. Biggest mistake people make is forget to shade. Alright, it says greater than here, but because of that negative, we'll actually end up going below it. Or again, if you have it isolated, notice it's now less than. So because it's less than, we shade below. Alright, if I give you something like this, I like these better than the last type of problem because you don't even really have to isolate the y here. Alright, 5 divides 30, 6 divides 30. So when it's in this form, just ignore the 6y. That's like setting y equal to 0. And then 5 goes into 36 times. So if I divided both sides of this equation, ignoring the 6y, if I divide that by 5, I get x, and I get a 6 on the other side. So the x-intercept is 6. Alright, and then if I go back up here and I ignore the x and just have 6y and 30, divide both sides of that by 6, and I get y less than 5. So there's 5. So there's my line. Okay, and again, if I isolated y, it would be positive, meaning the numbers in front of it is positive, meaning that I'm not going to switch this order symbol around. So it's less than, so that means I shade below. Alright, so again, what did I do? I used the x and y intercept, meaning ignore one of the variables at a time. 5x less than or equal to 30. That means x is less than or equal to 6. Okay, so we're going back this way. And then cover up the x. That's letting it equal 0. 6y is less than 30. Divide both sides by 6. Y is less than 5. So that means we're down below here. Alright, and so that means we're shading in this region. Alright, so practice it again. Once again, notice both of these numbers divide the constant. 2 divides the constant, 3 divides the constant. Ignore the y. 2 goes into 6 3 times, so the x coordinate, or the x-intercept, is going to be 3. Okay, cover up the x. 3y is less than or equal to 6. Divide both sides by 3, I get y is less than or equal to 2. So 2 is the y-intercept. Right? It's a less than, so right now it looks like it's below. The number in front of y is positive, so it's going to stay below. It's going to stay less than, so we shade below it. Alright, now, here's your first system. So you have multiple things going on here. Alright, so here's a line, here's a line, this is a vertical line, this is a vertical line, but remember, this is just a way to say x greater than or equal to 0, y greater than or equal to 0. These two things combine to tell you first quadrant. Okay, so you're just dealing with first quadrant stuff. Now your calculator can handle all this. It's kind of neat the way your calculator does it, but I'm going to show you. You need to isolate y first in both of these. Take the 4x over from both sides. I get the equation, or the inequality, sorry. Y is greater than or equal to 5 minus 4x. Okay, the bottom one, I have to do a little bit more work. First I subtract the x from both sides. Alright, and intermediately I'll have 4y is greater than or equal to 7 minus x, but I have to divide both sides by 4. Alright, so I get y is greater than or equal to 7 minus x in a parentheses divided by 4. So those are the two things I'm going to put into the calculator. Again, I'm going to ignore the order symbols for now. I'm going to say 5 minus 4x. Alright, and then come back in front. This is greater than, so I'm going to hit enter a couple times. There's greater than, meaning it's shaded above. And on the bottom one, parentheses 7 minus x, close parentheses, divide by 4. Alright, once again, go back in front. This is another greater than, so I'm going to hit enter a couple times to get that, make sure it goes all the way up to the top and it's not just the bold. Okay, now, the other two parts of this problem, the x is greater than 0, y is greater than 0, you can handle that. If it's just x and y, you can handle that in your window. So for x to be greater than 0 means we can't go down to negative 10, so we'll put a 0 here. Okay, so this goes from 0 to positive 10. All of those satisfy greater than 0. Alright, go down to your y minimum. Y has to be greater than 0 also, so no negatives. So start at 0 and now graph it. And our solution is what's shaded in both directions. Okay, so notice this doesn't get shaded at all. This is shaded horizontally. This is shaded vertically. All of this up here is shaded in both directions. Okay, so there's our answer. What's shaded in both directions. Now you can do this for all of them. You just have to make sure that you isolate these things, the y in these problems. Now a quick way to isolate y for the purposes of putting in your calculator, just do it in your head. Alright, here's y. There's an x over here with it, so I'm going to need to subtract. I'll always start off with a parentheses. Take the whatever's over there by itself to begin with. Take the opposite of the x. So if it's negative, make it positive, but here it was positive, so we subtract it. Close the parentheses and then divide by what's ever in front of y. So we divide by a positive 3. Okay? And then go down to the other, oops, sorry, this is a greater than. Right, because that's positive, it's going to stay greater than. I go down to the next one. Y, there's a 12 already over there, so we put the 12 minus 2x. Right, there's nothing in front of y, so I'm not going to divide by anything, so I didn't put the parentheses in there. Right, come back in front. This y, once again, it's positive in front of the y, so we're not going to change that. So it's less than, so that means we shade below. Okay, once again, this is x greater than 0, y greater than 0, so that's first quadrant. So I've already got it that way, the 0 and the 0 there, so I'm going to hit graph. And again, what are we looking for? What's shaded in both directions. So this is only shaded horizontal, this is only shaded vertical, not shaded at all. This is shaded in both, so that's region 2. The coordinates of all but one of the corner points of the solution are given in the graph. What are the coordinates of the last corner point? So what they're saying is they give us this region 2 as our solution. they give us this point. They're not giving us this point. Okay, so well, how do we find that point? That's the line. One of the lines they're giving us. This is the other line they're giving us. So this point is their intersection. So that's what we have to do. We have to find the intersection. Close this. Of these two lines. Now I've got them. Oops, that was from the last problem. If we got them isolated for y, then we could just solve it. But I mean, we can. It's just treat it like it's equal signs, and you're solving a system. So if these top two equations were a system of equations, all right, not inequalities, the intersection of these two things is that point we're looking for. So just solve this how you did before. If I multiply this by -2, I get a -2x, a -6y, and a -30. Alright, and then just bring this over, don't do anything to it. We get a 2x plus y equals 12. They cancel. We get a -5y equals -30 plus 12 is -18. Divide by -5. Alright, and we get y is equal to 18/5. Okay, so there's y. How do we get x? Just plug it into either one of these original equations. So x plus 3 times 18/5 equals 15. Alright, this won't reduce. 5 won't go into 3, so I have to multiply. 18 times 3 is 54 fifths. That's equal to 15, so subtract 54 fifths from both sides. Alright, 15 times 5 is 75 fifths. And then minus 54 fifths. And I get x is equal to 75 minus 54 is 21 fifths. Alright, so the third point is 21 fifths, 18 fifths. Alright, so to get an intersection, you're just solving that system, setting these things equal and finding out where they actually cross. Now, again, you could do this. Again, we have it graphed, so we could have used the intersect feature since that is what we're looking for. And there's our guess. Alright, 4.2, 3.6. Okay. If I go back to the main screen and I tell it to change x into a fraction, alright, there's the 21 fifths. And if I tell it to change y into a fraction, there's the 18 fifths. Okay, so you can do it with your calculator. But you know, it is something we've seen before, so you would be expected to be able to do it by hand as well. Alright, same thing here. What are the corner points of the solution region? So to know this, to know what the corner points are, you need to know which one of these 1, 2, 3, 4 regions are the solution region. So do like we've been doing. Isolate the y in these. And then find out which region we're dealing with. So again, you can do algebra to isolate y. I particularly like to use parentheses, there's the constant, minus the x term, close parentheses, and divide by what's in front of y. Okay, it was positive in front of y, so it was greater than to begin with, so it's going to stay greater than. So we're going to shade it upwards. Alright, the other one, there's nothing in front of y, so we don't need a parentheses. There's nothing wrong if you use it. So there's a 10 over there to begin with. It's a positive 4x, so we're going to subtract 4x from both sides. Close the parentheses. There's nothing in front of y, so you can stop, or you could, divide by 1. Alright, it's not going to matter. Dividing it by 1, not having the parentheses there, none of that matters. And then here we want a greater than, just like before. So we graph x greater than 0, y greater than 0 just means we're in quadrant 1. So this is quadrant 1, and what's shaded in both directions? Everything above there. So all of this out here is shaded. So it wants to know what these corner points are. So if I'm shading from here down to here, down to here, and then everything over to the right, the points are 0, 10, it looks to be 2, 2, and 4, 0. So 0, 10, 2, 2, and 4, 0. Okay, so it's just use your calculator to find out which of these 4 regions are shaded, and then find the boundary points for those 4 regions. Alright, now when you get to something like this, again, just isolate y in both of them. So let me highlight all this. So my system here is x squared minus 16. That's already isolated, so I can put that one in there. Alright, the bottom one is not isolated, or y is not isolated. So I got x minus y was greater than negative 4. Okay, so when I subtract the x over, I get negative y is greater than or equal to negative 4 minus x. Divide by negative 1, divide by negative 1. Alright, and I get y is, I divided by negative, so I got to switch the order symbol. Now, because both of these are negative and I divide by negative, they'll both end up being positive. So I can put 4 plus x or x plus 4. But make sure you got that less than in there now. So when I go to my y2, I'm going to put in 4 plus x. Alright. And now get your order symbols correct. So the x squared minus 16y is isolated, it says greater, so we're going to do the shading above. Alright, the other one, after we got y isolated, it's less than, so I'm shading below. Alright, now when I hit graph, oops, it's going from negative 20 to positive 20 in both directions, so you want to adjust your window to make it look like that. I still have mine in quadrant 1 mode. So negative 20, positive 20. Looks like they got their tick marks. There's 1, 2, 3, 4, 5 there, so it looks like they've got every, well, there's 4, so it looks like they've got them every 5. So negative 20, positive 20, 5 also in the y direction. Alright, and then after you've got all that in, now one of them should look like what you see here. What's shaded in both directions, alright, it's that piece right there. That's above the vertex, but below the line. So that would be this one. Alright, and then 8.1, question number 9, or similar question to your number 9. So 4,500 pounds is the capacity on the elevator. Average child weighs 50 pounds. Average adult weighs 150 pounds. We want an inequality that describes when X children or Y adults will cause the elevator to be overloaded. Alright, now let me minimize this so we can kind of look at both of them together. If this elevator is overloaded, that means that we have more than that 4,500 pounds. So that means the number of children that weigh 50 pounds times however many kids are on there, plus the number of adults that weigh 150 pounds times however many of them are on there, has exceeded that 4,500 pound weight limit. Okay, so part A wants to know what is the inequality. So there it is. 50x plus 150y is greater than 4,500. Alright, and then we want to graph the inequality. So for this one I would use what we were talking about before, ignoring one at a time, meaning ignore the 150y, let that be 0, and find the x-intercept. So 50 goes into 4,500, times, right, and then cover up the x, right, and you got 150 going into 4,500, so divide that by 150, right, and we get 30. So 90 is our x-intercept, 30 is our y-intercept. So there's that one, there's that one, right, and above it, okay, y is positive, the y coefficient is positive, it's greater than, so that means we're shading above. So take your value, oops, sorry, let me clear that. The reason why I'm clearing that is because I didn't use a dash line, because it's a strictly less than, or sorry, strictly greater than, I need a dash line. Alright, and then I'm going to shade above it. Alright, so that's the type of questions you're doing at 8, 9, and 10. You're coming up with some type of inequality to be solved there. Alright, this last question in your 8.1 homework is very similar to a question you guys did in the lab right before Thanksgiving on the turkeys. So anyway, you have a truck can only carry 1,700 pounds or less, right? 140 cubic feet of cargo or less, and they give you what the printers weigh, and they give you the volume, and they give you the microwave, that kind of thing. So you're doing the same thing that you guys did on that lab last week. Okay, so X is the number of microwaves, Y is the number of printers. So obviously that's where you're getting the greater than zeros. But then it's the other two things that you're solving there as well. Okay, so you're looking for the system that satisfies this no more than 1,700 pounds, no more than 140 cubic feet of cargo space. Alright, so just make sure you're paying attention to that.